Hi everyone, in this video we are going to discuss potable water. So what is potable water? Well, potable water is basically anything that you want to put into your system or inside of a human being. And so if we wanted to come up with a very, very simple definition of potable water, we would just say water used for drinking or cooking. So basically, any time that you could possibly use water and any human could possibly ingest it. That's what potable water is. So out of all the water that we have on this planet, how much of it is actually potable water? So let's kind of do a breakdown here. So water is going to be our global topic, and let's break it into two different sections. So for starters, let's say we have fresh water, and we're going to compare this to salt water. Okay, so this is the very top of it. And so now on our planet, about 97% of the water that just exists naturally is salt water. And so then the remaining 3% is fresh water. So already, right away, you should be saying, ooh, yikes, that's not very good for humans because we can't drink salt water. That does not hydrate us. It ends up dehydrating us. It's not good. Do not drink ocean water, okay? So now, fresh water. If we break that apart, we can do it in two different sections. We either have what's called groundwater or surface water. And so surface water is almost the easiest to explain, and that's just the water that exists on the surface. It's very, very easy for us to access. Whereas our groundwater is something that exists in aquifers, and so they are something that are deep, deep down underground, and they're basically water reservoirs, which you can access, but you have to pump it, and you need a well. It's not necessarily the easiest for us to get. So if we break down the easy stuff to access, the surface water, we can really break it into two different categories. We have glaciers and ice. That's your surface water. Or you have lakes and rivers. And so if we break this all down, the surface water that's stored in your glaciers and in the ice is about 99.7% of our surface water. So realistically, our lakes and rivers, there's only 0.3% of our water exists in the lakes and rivers, which is the easiest to access. Which is not good news for human beings, because this is our potable water. That's the water we can just drink naturally. 0.3% of all the water that we have on this planet is the easiest for us to access, and it's the best for us to drink, which is not good news. That's not good news. So let's assume we have 100 liters of water on the planet. Of water on Earth, okay? And that's crazy because that's not even close to enough water. But let's just assume that we have 100 liters of water. How much of that would be in the lakes and rivers? Okay. What volume is going to be in your lakes and rivers if only 0.3% exists of that? Okay, go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Don't get frustrated. This was definitely a two-step math problem. So the first thing you had to do was take into account the fact that we only have 3% of our total water is fresh water. So we have to multiply our 100 liters by 0.03 or 3%. And that will give us the expected 3 liters of fresh water, right? Only 3% of it, that makes sense. Now the second component is we need to figure out how much 0.3% of 3 liters is. So we multiply 3 liters by 0.003, and that gives us a value of 0.009 liters of water in our rivers and lakes. But that number isn't really useful. I would have preferred for you to report it as 9 milliliters. Now, think about that. 9 milliliters only is what we have to drink. It's our easiest for us to access water out of 100 liters. That's not very much at all, like at all. And so if you are somebody who lets the water run while you brush your teeth, stop that now. If you're somebody who lets the water run while it warms up, before you take a shower, stop that now. Please, please do not waste water. It is so, so, so valuable. In fact, let's write that down. Water is valuable. Okay, you have to treat it with respect. Please don't waste water. If you let it run, stop that habit right now, okay? Just turn the faucet off. It's a simple, easy motion. It doesn't take a lot of energy, so please, please, please do it. Now, let's introduce a concept that kind of gives us a way to evaluate if something is efficient in its water process or not. And so we've talked about something similar to this before in previous modules when we talked about our footprint or our carbon footprint. So what we're going to do in this video is talk about something very similar, but instead of carbon, we're going to talk about water. So we have this concept of a water footprint, which is a very, very simple thing. It's basically just the amount of water required to accomplish a task. So very simply speaking, how much water is needed in order to do X, in order to do Y, in order to finish whatever task it is you're talking about. And so for our course, I expect you to know the big 3 things on this planet that use the most water. And the first one is power plants, which probably isn't that surprising to you. But they actually use 50% of our water. So they are the biggest issue when it comes to water being valuable. They actually use, let me get this number for you, about 200,000 million gallons of water every day. So 200,000 million gallons of water per day in order to operate power plants. That's our first use of water, our first wasteful use of water. The second one is irrigation, which makes sense. You absolutely need water in order to have proper irrigation. And that accounts for about 31% of our water usage. And that's because it requires about 128,000 million gallons of water per day in order to have proper irrigation. Okay, and then again, this is a global average. And the last one is our public systems. So that could be your schools, your homes, your businesses, anything that's considered a public system, and that takes about 12% of our total water. And so just to put this into perspective, we use about 44,200 million gallons of water every single day in order to have and pump water to the public, so to have water fountains, to have it in the bathrooms, anything like that. The public actually takes about 12% total. All right, so now keep this in mind. I want to actually look at our water footprint for specific products. And so this is just a very tiny assortment of it. But you have to think about this in the grand scheme of things. So in order to drink a cup of coffee, it's not that you just had to go to the local grocery store and get your coffee beans to make your coffee. That you actually have to think about where the coffee beans were made, how they were made. Were they grown? Did you have to actually put water into the ground in order to grow the coffee beans? I mean, how did this whole system happen? And so just to kind of compare a couple things, if you look all the way here on our left side, for 1 cup of coffee, we see that it takes about 260 liters of water for 1 cup of coffee. I mean, that's crazy, right? That's crazy. Cup of tea, not nearly as much, only 27 liters, right, for a cup of tea. How about a glass of orange juice down here? We see that that takes about 200 liters of water to get 1 glass of orange juice. And then if you come all the way down here at the very, very bottom, this is always the one where my students just freak out when they see it. 1 cotton t-shirt takes 2,500 liters of water for 1 shirt. 1 cotton t-shirt. I mean, think about how cheap those are. You could get a 3-pack of a cotton t-shirt from Hanes or Fruit of the Loom or whatever for like, what, $6 or $7 at Target? But it costs us way more in terms of water. 2,500 liters of water to create 1 silly little t-shirt. And think about that. It's cotton. Cotton is a plant. You need water in order to grow cotton. It's this huge industry. The cotton industry is huge. But they're killing our planet because they use so much water. So I don't know. Is a cotton t-shirt worth it? I'm not sure. All right, last question. Let's end here. If you wanted to reduce your carbon footprint, so you're trying to reduce your carbon footprint, which one of these would you drink less of? Would you drink less of your orange juice? Would you drink less coffee? Or would you drink less tea? Those are your 3 options. Which one would you drink less of? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. All I wanted you to do was look at the table above and figure out what the water footprint was for each of these 3 beverages. So what we can see here is that for a glass of orange juice, it requires about 200 liters of water. Coffee requires about 260, and tea requires about 27 liters of water. So out of these 3 beverages, if you wanted to minimize your water footprint, you would absolutely stop drinking coffee. Are you actually going to do that? Probably not, but please be cognizant of it. Just take note of it. Understand that every single product out there has some kind of water footprint, and we just want to understand that water is valuable and we do not want to waste it. Have a great week. Take care of yourself and drink just a little bit of water.